Hi guys, here we are for the 7th week of CS204. Most probably we are going to record the lectures, and due to the pandemic we're doing it online. So we will have virtual labs today basically. Before starting, let's make some arrangements. So I'm going to explain the codes. Today we're going to have 2 examples. For the first hour, we're going to explain the first one, and the second one will be in the second hour. If you have questions, you can ask using the chat group. And if I don't understand what you're writing, then most probably you will be using your audio or maybe even video if it's necessary. And I will answer your questions in first come and first served order. So who asks first will get his answer first. I don't think I should leave it in the end. So maybe I'll explain like for 5 minutes, 10 minutes or so. And whenever I see it's necessary to do so, I'll start answering your questions, okay? Those examples will be related to your homework. We have seen some of those examples during the previous week, like operators and copy constructors, deep and shallow copies, but today we're going to see something else related to the operators, which are operator overloading. And we are going to see also operators which are free functions, not member functions only of classes, and we will see which one should be, actually must be free functions and shouldn't be member functions in our classes. So let's start. I'm sharing the screen, by the way. Okay, so the codes for today are those: the MathVector and the complex number class. We'll start with the MathVector first. You don't have to download the code, basically. You can do it later on. You can just follow me. So this is the MathVector. As usual, we have the MathVector class, which we have divided in the corresponding header and CPP file. So let's see what's going on. Okay, and we test this class in our main.cpp file. So again, if you have questions, you can just type them, and I'll see that you have questions. And whenever it's proper to do so, I'll answer your questions. So this is our MathVector class. Maybe I think I should run the code first. Let's see the output of the code, and let's see how did we get that output. And then I'm going to explain the class and the CPP file, the main CPP file. Okay. What's the problem with this one now? Okay. Hopefully it's going to work this time. My computer is slow because I've been using other stuff and doing some experimentation, that's why. Okay. Basically here we're going to have a vector, and this is our output. So we're creating a vector. This is our first vector, second vector, third and fourth, and we add 2 vectors. I'm adding the second and the third one, and this is the result. So I'm adding them as you do it in your linear algebra course, basically, components index-wise. Then I'm concatenating, merging vector 1 and vector 4 over here. In this part over here, I'm concatenating, merging vector 3 and 1. And I'm doing some other stuff, we'll see them. So this is our output. Now let's see what do we have in this class. So we have the constructor, which is the default constructor. We have a parametric constructor, which takes an integer as a size, as a parameter. By the way, the private variables are a pointer, which is an integer pointer to a vector. So basically, we are going to keep this, we're going to dynamically allocate this vector, MathVector, and size is the number of elements that this vector is going to have. Okay, so we just keep the pointer to this vector and the size of the vector, nothing else. And we have those functions. So as I said, copy constructor, parametric constructor, I'm sorry, this is the default constructor, parametric constructor with integer, copy constructor, destructor, operator equal, plus equal, operator plus, operator concatenation, meaning merging two vectors, set element, get size, and set size. So let's see what do we do with them. Basically here, I've drawn them. So this is, hopefully you can see that. And this is how our class looks like. This is it. So this is our vector. And in our class, which is our MathVector class, we just keep the pointer to the vector and the size of the vector. And here are our functions. Now let's explain them one by one. Let's go as usual with the copy constructor. So basically, when we create a new, when you declare a new object of the class MathVector, the size will be 0 and the vector will be the vector pointer will be pointing to null. So basically, this is what we do. We set this guy to be null. Okay, like this maybe. Okay, and the size is 0. This is it. This is when we call it without any parameters. If we create a new object of the class MathVector, I've seen from previous years that you confuse the notions of class and object. So as class, we are whole human beings, and I'm one object of that class, okay? I'm one instance of that class, okay? So the class is MathVector, and if we declare a variable of that class, that is called an object. So when we create, so we saw the default constructor. When we create a new object of the class with, this is parametric constructor basically. We always call the constructors when we create or declare a new variable, new object. And this is how we do it with this parametric constructor. Basically it takes an integer and I'm dynamically allocating a vector of p size and put the size parameter, the number of elements, to be p size, as simple as that. So basically I'm doing something like this. Okay. So if p size is, let's say 10, and I'm just writing here 10, okay, or whatever, size or whatever. And then I'm just allocating memory vector, okay, and the first element of this vector is assigned to my vector. This is it. This is what I'm doing basically. Maybe I should copy this one, not paste it. So this is how I use this parametric constructor. Now you might ask, what are the values of the vectors? Well, they're unassigned, or maybe in some compilers they are by default zeros, since this is an integer vector. So the values of the elements in this vector are most probably zeros. And I have here 10 elements, so size is 10, from 0 up until size minus 1, 10 minus 1. Set element. Set element is taking the index and an element. Okay, so this is my, so we saw the first one, this one basically. Maybe I should underline it somehow. Okay, so MathVector was done. MathVector is also done with integer parameters. Now we have the set element, so we are doing this one now. Set element is basically doing the following. So this is my function set. I take an index and element, and I'm making the index of the vector with the value of that particular index to be equal to the element, as simple as that. Okay. Now get element, if with set element I'm setting it, with get element I'm returning the value of the vector with that particular index. Okay, so this is get element. Then we have set size, just as it was the case with set element. With set size, I'm setting the size of the vector, and of course, when I do it, I say size. This size is equal to p size, the parameter, and the vector is equal to a new int. So basically, I'm allocating a new dynamic memory, a new vector, which has size number of elements, and of course, I'm assigning the value of that vector, the value, actually the address of the first element of the vector of the newly allocated vector to the vector pointer. Get size, I'm returning the size. So return size, it's an integer. So far, so good. Now, we have a copy constructor, and copy constructor is called when I want to create a new object, and I want the newly created object to be a copy of another object that already exists in the memory. So what do I do? Basically, let me enlarge this guy. So let's assume this is my copy. Okay, here I might put some values, like, I don't know, maybe a 3. Let's make them black. So 3. Then I have maybe 5 here. Then I have, I don't know, 7. I don't know, maybe I might have in the end 13 in the last element. Never mind the values. So this guy now is my copy. Let me write the name. This is an object that has already been created. Maybe I've set those values using set element, etc. So this is my copy. Okay. So what I'm doing basically is the following. Okay, of course, this copy has all of the member functions as the original class. I didn't write them, I didn't have place, I just write the vector and the size. So what I'm doing is the following. So since the copy constructor is a kind of a member function, it's inside of the class, I'm just saying size, okay, is equal to copy.size. So basically, this size is equal to, this is my copy.size. Or if this has, like, I don't know, 10 elements, let's say, I'm making it 10. Then I'm saying vector is equal to a new integer size. So basically now I'm dynamically allocating. I'm allocating. Never mind. This vector over here, okay? And it's going to be equal to the copy.size. Now, after dynamically allocated, it looks exactly like this, and I have to fill the elements one by one. So with this for loop, I just fill them up. As simple as that. Okay, so I have this class and this loop, and I fill those values one by one, like 3, 5, 7, and 13 in the end. This is what I'm doing. This is my copy constructor, basically. Okay. Now, besides my copy constructor, I have operator equal. Operator equal is when I've already, so constructors are called when I create for the first time an element, an object. But operator equal is when an object has already been created and I want to make it to be equal to some other object that I've already created and it's over there. Usually when I'm dealing with operators, I have the left-hand side, if they're binary operators, they have 2 operands, the first and the second one, like addition, subtraction, multiplication, etc. I have the left-hand side and the right-hand side. If the function that I'm explaining is a member function, then I have always one parameter because the left-hand side is assumed to be the class itself. Okay, so basically, if let's say, maybe I should comment it out. I'm writing the code. So I'm creating now a MathVector. Let's assume that I already have another MathVector v1, okay. And I say v1 with 10 elements. Okay, I'm calling the integer with 10, okay. I'm calling the constructor with 10 elements, with integer size, which makes the vector to be 10 elements, to have 10 elements. Now, if I say set element, if I want the 0th index to be, let's say 5, this is what I do. Index 0, its value is 5. Now, I'm creating another MathVector. I'm commenting it out, so I don't want to have errors later on. So MathVector v2. And then if I say that v2 is equal to v1, well, what I'm doing, I'm calling operator equal, okay? And v1 is now the right-hand side. And v2 is the left-hand side, and I don't have to give the left-hand side because, as I told you, the class itself is the left-hand side, since operator equal is a member function. As you see it here, operator equal is a member function. So let me check it also. Where's operator equal? Now I'm doing this one. Okay. So what do we do? As I explained to you during the last week, all of the classes, when you create them, they have this pointer. It's basically a pointer which points to the newly created class. It's this pointer, okay? All of the classes have it, okay? And it's a pointer that points to the object that calls the member function, okay? To the object itself. Fine. Now, what I'm doing is the following. So, if this is not equal to right-hand side, okay, meaning if this is not equal to, now the name of this guy is not going to be copy, it's going to be right-hand side, basically. So let me make it right-hand side. I'm writing it. So this is the name of this new variable. So if this is not pointing to right-hand side, in this case it's not, then what I'm going to do, well, I'm just making size, this one to be 0. So this is going to be 0 now. Okay. Then I'm deleting the vector that I'm already pointing to because I've already allocated it. So I'm deleting it. Okay. It's deleted now. Then I'm saying size is equal to right-hand side dot size. Okay, so this size is equal to the right-hand side dot size. If it's like 10 again or 12 or whatever, I'm writing it. Let's say it's 12. Okay, so size is, I'm doing those two lines now. So size is equal to right-hand side size. Let's say 12, because the value of right-hand side is 12, assumingly. Okay, it's 12. Then what I'm doing, then with this for loop, so, okay, I made the vector and I'm allocating vectors equal to new in size. So I'm just allocating a new vector. I deleted the previous one. I'm allocating this one. I copy pasted because I'll need it later on. Okay. So this is my vector. And with the for loop, okay, with the for loop, I just set the elements of the right-hand side, one by one, to be equal to the newly created vector. So basically I have 3, 5, 7, whatever. I'll do the same. I have 3, 5, 7, etc. Okay. Finally, I return this. Now, the question is the following. Now, I made the left-hand side to be equal to the right-hand side. Why do I return this? Well, the answer is obvious. What if I have another vector, which is v3, and here I'm saying v3 is equal to v1. Now, for the v2 is equal to v1, we saw it's working, okay. v2 basically is becoming the right-hand side, which is v1 in this case, and it's working. However, if I want to assign an element to v3, and if I don't return anything from the operator equal, then this part over here, when the function is finished, is not going to have anything. It will be something which is empty. And I'm saying v3 is equal to nothing, something which does not exist. That's why I'm returning this, star this. So star is a pointer. So this is a pointer. And when I say star this, actually I'm returning the whole object. Okay, I'm returning all of this object. Okay, and later on, I'm assigning it to I'm assigning it to v3 over here, okay, which is again calling the function. So this is so basically for cascading purposes, we always return this in those this kind of operators, because not only with equal, it can be something like this, v4 plus equal to this one, or I can say v5 is equal to v6 plus, in brackets, in parentheses, this one. So for cascading purposes, I need to return this stuff. Otherwise, if I'm sure that I'll never ever in my code have to do something with cascading operators, then v2 is equal to v1 is okay, and I just don't have to return this anymore. But it's only for one assignment operator, not for more than that. Now the question is the following. So we saw this part of the code now. We saw why to return the object itself. Now the question is the following. Why do I say this is not equal to right-hand side? Well, what happens is the following. I can say v1 is equal to v1. In that case, the right-hand side is not this guy. Rather, the right-hand side is this one. The actual object that's calling the function, the member function. So this is my right-hand side. Okay. And if this is not equal to right-hand side, then I don't have to make any changes. Okay, just return this for cascading purposes, so I can say v2 is equal to v1 is equal to v1. This is a must, basically. We must do that, because if we don't do this, what we're going to do is we always delete the vector and make size v0. We are going to lose the data, basically. So if I don't check this part, sorry. If I don't check this equality part, what I'm going to do is the following. So this v1, let's say we're dealing now with v1 is equal to v1. I'm just basically going to make size be 0. So size is now going to be 0 according to the code. So size equal to 0 of the right-hand side, which is myself, basically, the vector, the object that is calling the function. And I'm going to delete the vector, okay? If I'm doing self-assignment. And now I'm saying size is equal to right-hand size, but hey, right-hand size and size are the same object, okay? And now I lost my data, so I cannot proceed. That's why it's very important in the beginning to do this check. Check whether I'm not doing self-assignment, okay? Because if I delete the vector, I cannot take it back anymore. This is it. And this is only for operator equal. Okay, now let's see another operator, which is operator plus equal. So basically what we're doing with this operator is the following. So basically, okay, we have this. Okay, let's assume the values are the same. So this is my object. Let's have I have here like maybe 9 elements or whatever. And my right-hand side is the other guy, which is this one. This is my right-hand side now. Maybe I should copy this part over here. So this is my right-hand side over here. What I'm doing with operator plus equal is the following. As you can see, from 0 up until size, the values of my vector will be current value plus the value added from the right-hand side, okay? And finally, for cascading purposes, I return this. So basically, the right-hand side has the values. Maybe I should change them like 1, 2, 3, whatever. Okay. I have the values like this, 4, then I have here, let's say 7, and 7 again, etc. What I'm doing with this for loop is basically vector I, which is this one, vector I, I'm accessing the elements, is equal to vector I plus right-hand side vector I. So basically 3 plus 4, it's going to be 7 over here. Oh, 3, 5, 7. So it's going to be 7 over here. Then I had the previous value here, 5. So 5 and 7 corresponding is 12. So I'll have 12 here. Then the previous value over here was, if you remember, I think 7 again. So 7 and 7 are 14. So this is what I'm doing. This is what I mean by operator plus equal. Again, the left-hand side is the object which is calling this member function, and the right-hand side is the parameter that I take, and usually I take them as reference. And it's good if I don't want to change the right-hand side, I maybe can put const here. It won't be a mistake, okay? And I'm taking it as a reference because I don't want to, if it's large object, I don't want to make a copy of it. Okay. So, and finally, for cascading purposes, again, I'm returning this. And I'm not creating, when I return a value, I always return a copy of it. And when I return a copy of it, I return it with using the copy constructor, if it's an object of a certain class. But when I'm returning a reference, as is the case over here, I don't have to do that because it's a reference right now. And I'm doing it, as I said for cascading purposes. So if I say V2 is equal to V1 plus equal to V0, then if I just use this one, V1 plus V0, then okay, V1 adds the elements of V0 in order to itself. But then I'm assigning V1 to V2, then I have to, in that case, I have to return this for cascading purposes. Operator plus, again, here I'm not making any changes. That's why I'm creating another. So here we are, another object using the, if you remember, the parametric constructor over here, this one, which takes the size of the vector as a parameter, as an integer. So basically what I'm doing with this one, I'm creating the result, and the size of the result is right-hand size plus size, okay? And the assumption is here that the left-hand side and the right-hand side have the same size, same number of elements in the vector. So basically what I'm doing is the following. Let me show it to you, and I'll do it with, explain it with code. So this is my right-hand side, and this is the calling function. And if you remember here, I'm creating a new vector, MathVector, with the name of that is result of the newly created vector. Okay. So this is that guy. So this is the result. Okay. And the size of, it's assumed, okay, if this is the original object that is calling the operator equal, so operator plus actually, we saw operator plus equal. So I'm dealing now with operator plus. This is my left-hand side. Okay, always this is the left-hand side, LHS. And I'm taking right-hand side as parameter. I'm assuming that the sizes of the two of them are the same. And what I'm doing is the following. I have this result. Okay. The size is the same as those guys. So it's, if it's 12, it should be 12 in both of them. Let's say it's 12 here also. Size is 12. And size is 12 over here also. And this is a newly created object. And I'm saying that the 0th element of the result is equal to 0th element of right-hand side and left-hand side. So 4 and 7, it's 11. So I'm writing 11 over here. Then 12 and 7 is 19. So I'm writing 19 over here. Then 14 and 7 is 21. And I'm writing 21, etc. till the end. Finally, so this is what I do. I create the result using the integer parametric constructor. Then I fill up the values. Result vector is equal to vector I. When I say vector I, that means my vector, the calling vector, the left-hand side vector. But since it's a member function, I don't have to use any dot because I can access it. It's part of me. And then I'm saying right-hand side dot vector I, adding them. And finally, I'm returning the result. Why am I doing that? Of course, for cascading purposes. So I can use something like this. V3 is equal to V1 plus V2. Okay? This is it. By the way, when I'm returning the results, as you see, I'm not returning a reference, so I'm calling the copy constructor. Okay, I'm actually returning a copy of results, of this result over here. And when I return a copy of this result, it's going to be, I'm going to do it with copy constructor. I think we have a question. So let me take your question then. Okay, so the question is the following. Since we assume the right-hand side and the left-hand sides are equal, if right-hand sides and left-hand sides are not equal, is it give, it will, you know, what's going to happen? The following. So it's not going to be an error if the left-hand side has more elements than the right-hand sides. But because if you see here, when I'm assigning the results, when I'm creating the result class, the result object, I'm sorry, I'm making the size of it to be equal to right-hand size, okay? If the left-hand size, this one, has more elements than the right-hand size, excuse me, less elements. So if right-hand side has 10 elements, and I have, or the calling class left-hand side has 5 elements, then when I'm going to assign, when I'm going to try to access the 6th, the 7th element, etc., I'll have an exception error, which is called vector out of subscript error, okay? Because I have 5 elements and I'm trying to access the 6th, the 7th, etc., okay? Otherwise, if the right-hand side has less number of elements, let's say it says 5, and the left-hand side has 10 elements, then I'll not have this error. Of course, maybe this is not done professionally because we should do checks and what if this and that, but I mean, we don't care about this usually. But if we are going to deploy it as a class and for use for people to use it around the world, that you should be very careful. And you're not going to do it in 5 or 6 lines, maybe in 50, 70 lines, etc. You're going to do a lot of checks, but it's just to show you, for the purpose of showing you how operator works. Okay, another question is the following. We have const at plus equal operation while we don't have it at plus operator. Can you explain the reason of it? So plus equal, where is plus equal? Okay, it's like this. When I'm returning this as a reference, that means I'm not creating a copy in operator plus equal, okay? If I'm, so I'm taking, so this is a reference, but basically this part. Since it's a reference for cascading purposes, that means that if I'm creating a copy of another one, that other one can access this reference and it can change it. And I don't want it to happen, okay? That's why I'm putting const. That means that I'm going to return a value, okay, which can be used for cascading purposes, but the other guys are not allowed to change it, okay? Because if I don't create a copy of me, and if someone is accessing my data, he can change my data, and I don't want that to happen. But also I want to use it for cascading purposes, okay? On the other side, operator plus, I'm creating a copy. That means that, okay, you can do whatever you want with the copy. You can change it, but because you don't change the original. So this is it. Hope that this is the reason I don't have const over there, because I'm not using reference, okay? With reference, I can change the original. With a copy constructor, you can change the copy. I don't care. I have the original anyway. If there are no questions, then we can proceed with other member functions. Operator, I don't know how to call it, concatenation, okay? So basically what we do here, we concatenate two vectors, merge them. So, okay, there are no questions. I'm going to close the chat right now. So again, I'm having the results, but the result now is going to do the following. It's going to concatenate. It's like, you know, I'm taking a copy of this one. I'm copying it of the left-hand side and also of the right-hand side. And I'm appending them like this. So this one. So I have the size of left-hand side. And also I'm taking this one, a copy of it basically. And I'm putting it over here, like appending it. I don't want to do it right now, but you got the idea, right? So, and this is not, the indexes are not 0, 1, 2, okay? I just continue with size, etc. Okay? So the indexes are not like this. So this basically, you can assume that the vectors continue, okay? Well, maybe I can do it like this. Okay. No. Never mind, you understood the idea, I suppose. Okay, maybe like this only. So basically, and I have here a lot of dots. And this is what, like this. I don't have a touchpad, unfortunately. It would have been easier with touchpad, but never mind, okay? So this is what I do with this function. I'm merging two vectors. Okay, and this is size -1, and in the end I have, okay, the size of this guy is, I don't know. So if the sizes are the same, it's going to be 2 size -1, or the size are going to be size plus right-hand size dot size, the index -1. Okay, the index of the last one. So how do I do that? Well, I create this result, and what is the size of this vector? Well, it's the size of the left-hand side and the right-hand side, and the left-hand side is the calling object, so I create the size. Then I go take the elements one by one, okay? From 0 up until size, vector I is equal to result.vector I is equal to vector I. Then from size up until right-hand size plus size, okay, then result vector I is equal to this guy. And finally, I'm returning the result. For cascading purposes, I'm returning a copy of it. In the end, I have the destructor, of course. What do I do with the destructor? It's very simple. I just set the size to be 0, and I delete the vector. This is it. So with the destructor, I basically, if this is the object that I want to destroy, I make the size be 0 here, so it's 0, and I just destroy the object. Okay, this is it. And when I destroy it, usually it's pointing to null. Okay, this is it with the class. So basically we covered all of the examples, all of the member functions actually, including get element, set element, all of them. The copy constructor, the destructor, everything is explained. Now let's go with the corresponding CPP file. Let's explain that one. If there are no questions, I can continue. Apparently there are no questions, so let's see what we are doing here with the CPP file. Okay, in the CPP file, I'm taking as a parameter another object of the class called vector, and I'm printing it. So basically, what do? I just print those brackets, arrow, whatever, and starting from 0 up until vector get size. You remember the function get size. This one, it returns the size of the vector. This one, get size. Okay, so it returns the size of the vector. So starting from 0 up until the size, then I'm using the get element. When, if you remember, get element returns the element with a certain index of the vector. So I'm returning the elements and I'm printing them. Okay, we're using comma. In the end, I'm printing the last element using this. Okay, I print the last element, get size -1, and I'm closing the brackets. Here I opened those brackets, or how do you call it? Angular brackets, whatever, and I close it here. This is it. Now let's go to the main function. What do I do over here? Well, maybe I should run the code over here and see what's going on, and I'll run it twice. You'll see why. Okay. Yeah, I'm going to run the code, and simultaneously we're going to see the output of the code. So I'm creating here. Maybe I should. Okay, this should be enough. Okay, so here I'm creating a new MathVector, and here I'm calling the empty constructor or the default constructor. We'll see how it works. Then I'm setting the size of V1 to be 7. Then over here, I'm creating V2 and V3, with both of them have 5 elements. Then I'm creating new MathVectors, objects, some result, it has 5 elements. Concatenation results 1, it has 12 elements. Concatenation result 2, I'm calling the default constructor when I'm doing that, okay? And so I'm saying here in comment, I'm calling different constructor. Here, when I called some result 5 and some result 12, I'm calling the the parametric constructor, which takes an integer as a parameter. And here with con result 2, I'm calling the default constructor, which doesn't take any parameters. So always when you create, this is what we want to show you. Just as we have different types of operators, we have different types of constructors. If the constructor doesn't take any parameter, it's a default constructor. If the constructor takes some parameters, it's called parametric constructor. And if it takes another object, if the constructor takes another object of the same class, then it's called the copy constructor. We have the empty vector over here also. Now from 0 to 7, I'm setting the elements of v1 to be like this, I multiplied by 7. Then I print v1, and this is my output. When I print v1, you see everything is multiple of 7 over here. When I print v1, then I set the elements of v2, and I print v2, and they are I plus 1. That's why I have 0, 2, 4, 6, 8. Okay. Then I set the elements of v3, and I print v3 over here. I'm sorry, when I set the elements of v2, so the values are 1, 2, 3, 4, 5. And for v3, I set them as I multiplied by 2. That's why they are multiples of 2. Okay, as you can see it over here. Okay, then I call the copy constructor, and I say v4 is equal to v2. Okay, so when I print v4, you see that v4 and v2 are the same because I'm creating basically a copy of v4. Now let's see the operators plus and equal. First of all, I'm calling v2 plus v3. I'm calling operator plus, and the result is assigned, is returned and assigned to some result. Okay, so when I print the sum results, v2 plus v3, it's 1, 4, 7, as you see it. Okay, and basically, if we had 1 plus 0, it's 1, component-wise, index-wise. 2 plus 2, it's 4. 3 plus 4, it's 7. 4 and 6 are 10. 5 and 8 are 13. Okay, then the operator plus equal. So after I called it, you see v4 is equal to v4 plus v2. Basically 1 and 1, it's 2. Okay, then 2 and 2, it's 4. Then 3 and 3 are 6, because you remember v4 was a copy of v2. 4 and 4 are 8, 5 and 5 are 10. Okay, so this is when I print v4, this is the value of v4, okay? And it's v4 is equal to, v4 is actually v4 plus v2, or we'll write it as plus equal. Now we see the concatenation. So concatenation result is equal to v1 concatenated with v4. So when I concatenate v1 and v4, this is what I get, which is exactly concatenation of v1 and v2. I print the concatenation result, we see it. I do the same with v2 and v3 and v1. So v3 is, okay, 0, 2, 4, 6, 8. We have it over here. And v1 is 0, 7, 14. So later on, I'm appending 0, 7, 14, etc. to the end. Then I'm using the assignment operator. I'm saying empty is equal to concatenation result 2. And we see what we have here. This is the result. Then I'm saying v2 is equal to concatenation result 1. And I'm saying assignment of v1 to and v4 to v2. And when I assign v1 over here and v4 to v2, this is my v2. And I print v2, of course, and this is it. Now, before finishing, it's good to see when we call copy constructors, parametric constructors, etc. That's why let me run the code, but in a different manner. Okay, like this. I should put here a breakpoint. So I'm running the code now. Okay. Not this one, this one. Okay. So here, let's see what I'm calling. I can use F10, F11, and I'll do that. But initially, step into means let's see in the first line, when I call this line, MathVector v1, what am I calling? Of course, I'm calling the default constructor, but let's see it. So build, debug, step into, and really I'm calling the MathVector. Now I'll go debug, step over, I just go through the lines. I'm setting the size to be 0. Then again, F10, step over, the vector is pointing to null, and finished. Now let's go to the second one. v1 set size, of course I'm calling the set size. So let's see, step over. Oh, it should be set step in, never mind. Here I'm calling constructor with vector size. So debug, step into, I'm calling the constructor which takes an integer as a parameter, okay? So when I go debug, step over F10, I'm just setting the size of the vector to be p size and the variable size to be equal to p size, and this is it, okay? I'm doing the same with this line also. Now here I'm declaring 1, 2, 3 objects of the class MathVector, and let's see what do we do here. So I'm going with step into. Basically, I'm going to create some result first, then concatenation result 1 and concatenation result 2. The first two use the parametric constructor with integer as a parameter, and the last one is default constructor. So let's say step into. Now I'm using the parametric one. This is for the first one. Step over, I did it. Now I'm still again in the same line. That's why if I say debug, step into again I'm calling it for the second object. Again, I'm creating it. Now I'm still on the same line and I'm creating this one, concatenation result 2. So if I say debug, step into, now I'm calling another constructor, which is the default constructor. Size is 0 of this one, and the vector is pointing to none, okay? Here I'm calling again the empty constructor or the default constructor. Now I'm calling set element several times. I don't have to show it. I'll just run through step over F10, 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 okay? Okay. Now I'm printing V1 is equal to, you can see at your screen that I've printed V1 is equal to. Now, I'm calling the print vector function, but you remember the print vector takes another parameter of the class vector. However, when I do this, I call the copy constructor. So let's see, if I say step into, you see, I'm calling the copy constructor because I'm sending a copy of that one. It's not a reference. Always, when you call the function, you're sending a copy of that object. If it's not a reference, of course, you don't do that. So here, this is what I do. Size, I set the guy. Okay. Several times up until it's finished. When it's finished, if I say again, debug, step into, then I go to the print vector now. And I call the copy constructor for this vector guy over here. Now let's go to those guys line by line. I'm printing them, as you see, as I go through the code. I'm printing them one by one. I'm finished. I'm doing the same with the set element for V2. I'm printing V2. I don't have to show it again. I'm calling the copy constructor again. I'm not going to show it. V3, I'm setting the elements. Okay, I print it. Now here I'm calling the copy constructor. So basically I can do something like this. Debug, step into, and you see I'm calling the copy constructor over here. Let's see what we do. Okay, I'm using now step over again. Now this is interesting. Now first I'm going to call V2 plus V3. That's why I go debug, step into, and I'm in the operator plus, inside of the operator plus. And that operator was taking a reference, okay? If this guy wasn't a reference, I would have called the copy constructor and then continue with operator plus. But it's a reference, so I don't create a copy. That's why here I'm calling now the parametric constructor for the results. Let's check it also. Debug, step into. So I'm calling this parametric constructor. Okay, now let's go through all of the code. This is what we do over here for size times. And when we are returning the results, you see I don't have here, I'm not returning a reference, I'm returning a copy. That's why if I say debug, step into, actually I'm calling the copy constructor. Because I'm not returning a reference, I'm returning non-reference variable. This is it. Now I finished with V2 plus V3, and the result was returned as a copy. Okay, that's why it's not const. I can change it. Now if I say again debug, step into, I'm going to call the operator equal. Okay, operator equal. I don't call the copy constructor for operator equal because the parameters are references, you can see. I go through this guy again, so F10, 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 I'm deleting it, etc., creating the vector. After deleting it, assigning and the values one by, I return this, the value. and I don't create a copy right now because I'm returning a reference, I go here, I print the vector, etc. I'll just do this one, debug, step into, operator plus equal. So I'm doing this stuff. And I'm returning now this, printing it. Now for the concatenation result, first of all, I'm going to call the concatenation function, then the assignment operator. So step into, okay, this is it. I'm concatenating two vectors into the results. Okay. Now when I'm about to return the result, I return a copy of it. I don't have to show it anymore. We have shown it several times. Now I'm finished with this guy. You see why we return a result here? Because we're going to use it again for the concatenation result now. Now if I say debug, step into again, I'm calling the operator equal, okay, which we already saw it. Okay, so basically this is how it works till the end. I'm printing everything. You have an idea of what's going on, and this is it. Do you have any question? If you don't have any question, then we will finish here and we will be back in like maybe 10 minutes because I have to save the video. Okay. Well, let's finish here, and if you have questions, you can ask me the questions during the second class. We'll be back in 10 minutes after I save the video. See you.